Hey guys, good to see everyone again. We are on the countdown here to the end. I'm going to miss you guys terribly. On our last test, we're going to have two more algebra skills and concepts that will be there that was not on the quiz. The first one of those is systems of equations. The second one is completing the square, and we're going to use completing the square to write the equation of a circle. First, we're going to get into systems of equations. Now, we've done these. We had these first semester, but it's been a little while, so we're going to go over this again. The general idea for systems of equations is you can try to do substitution, but that's not real easy a lot of the time. So what I do is I try to get my equations in this format. Something x plus something y equals a constant. Ax plus by equals a constant. And our first example here is already set up in that format. So the next thing we try to do is eliminate either the x coefficient or the y coefficient. You can go watch the video from a long time ago if you want, but remember that we can multiply or divide any row by any number we want, and it'll stay equal. So our goal is to figure out something that these numbers, the coefficient for x, both go into, or the coefficient for y. It doesn't matter which one you pick. But I'm going to choose the letter x. So 3 and 4 both go into the number 12. How do I make 3 turn into the number 12? I'm going to multiply it by the number 4. How do I make 4 go into number 12? I'm going to multiply it by the number 3. But I can't just multiply the first number. I have to multiply every number. So I'm going to take that top row and multiply them all by the number 4. And that's going to give me 12x plus 8y equals 60. And I'm going to multiply the second row by 3. But the thing is, I want my signs to be opposites, right? That's a positive 12x. I actually want this one to be negative 12x. And in order to do that, I need to multiply it by negative 3. So, and I got to do that to every term in the equation. So negative 3 times 4x is negative 12x. Negative 3 times 7y is negative 21y. And negative 3 times 7 is negative 21. And so now I have these two equations that come from the original equations. And the other property we talked about in the past was that you can add or subtract any two equations and the result will still be true. So I'm going to add these two rows together. And what's going to happen is I'm going to have 12 and negative 12 cancel out. They're gone. Fight to the death at 0x. Over here I would get negative, what would that be? Oh gosh, 13. Negative 21y and positive 8y would be negative 13y. And then 60 and negative 21 would be positive 39. Now it's a much simpler algebra 1 equation, and we know that y would have to equal negative 3. Okay, so then what do? Well, we go back and we plug in our y into one of the equations. And you could really do both, because you should get the same x for both. I'm going to choose this equation right here. So 3x, if I plug in, what was it, negative 3 for y, that would be 2 times negative 3 equals 15. So that would be 3x minus 6 equals 15. So 3x equals 21, x equals 7. And so this is actually the coordinate 7 comma negative 3. Remember that this format, these are actually lines. You could solve it for y and make it y equals mx plus b. This is the coordinate 7 comma negative 3 where those two lines would intersect. And that would be your final answer. X equals 7 and y equals negative 3. The second one's a little tougher because it's not in the correct format. So our first job is to put the equations in this format up here. So for this equation, I'm going to add 3x over. That would give me 8x. I'm going to subtract 8y over, give me minus 8y. So this moved, and then I want to move the 22 to this side. So I'm going to subtract 22, and that's going to give me negative 52. If you can, I like reducing, so I can divide all those numbers by 4. 8 divided by 4 would be 2x, divided by 4 would be negative 2y, divided by 4 would be negative 13. So I like to pull out a GCF right away. Remember, smaller numbers are easier to work with. All right, this equation, same idea. I'm going to keep x positive, so I'm going to subtract 4x. So that would make me have 2x, so that's gone. I am going to add 3y. That would give me 2y, so that's gone. And then I would leave the 11 alone. All right. Well, look at this. After we reduce, we already have a situation. So if I bring this over here, we already have a situation where the y's are going to cancel out. Real convenient. I didn't plan for that, but that's the way it worked. So if I add those two rows together, I would get 4x. The y's would cancel out, and that would equal -2. So x is going to equal -1/2. So if I go back and plug that in, it doesn't matter where, I'm going to plug it into this blue equation right here just for funsies. That'd be 2 times -1/2 plus 2y equals 11. So that'd be -1 plus 2y equals 11. 2y equals 12. Y equals 6. So we have the coordinate -1/2, comma 6. And you can test those out. If you plug those numbers into these originals, that should check out. If it doesn't, then you know you did something wrong. All right, so then here's the geometry version of the question. This is an inscribed quadrilateral. It's in our properties packet, but we know that the opposite corners have to add up to 180. So it's going to be a little bit of writing here, but I'm going to take those opposite corners and add them up to 180. That's going to be 15x minus 4y plus 45 plus 15x minus 4y plus 25. Those have to add up to 180. Combine like terms, and I want the format to be something x, something y equals a constant. So that would be 30x, that'd be -8y, so I took care of all that. 45 plus 25 is 70. Move the 70 over, that's going to be 110. So I subtracted 70 over here to cancel out those two numbers. Okay, well, I can divide all those by 2. That's going to be 15x minus 4y equals 55. So there's equation number 1. Equation number 2, I'm going to do these two corners. Those also have to add up to 180. It's a property that we learned. We went over it. That's going to be 60x minus 6y plus 60 equals 180. Ooh, pay attention. I messed up the first time I did this problem in class. I said it was 6x. So kind of silly. All right. So I'm going to have 60x minus 6y. Move the 60 over, I have 120. I can divide all those by 6. 10x, divide by 6, 1y, divide by 6 equals 20. And so if I stack these together, my two equations, I got this guy, I got this guy. I left some of its friends behind. Oh no, okay. Equals 20. All right. I want to find a least common multiple. I would do the letter y. I can turn this into the number 4 pretty easily. Otherwise, over here, I'd have to have like a least common multiple of 30, and I'd have to multiply both rows. But if I get my y's to be the same, I'm going to multiply by -4. And what happens, I'm going to put it above, is that would give me -40x, and -4 times -y would be plus 4y. Now, those are going to cancel out, equals -80. And so these are the two rows that I'm working on. If you want to see it, I'll drag it down here, maybe a little easier to see. Now I got to add those. And that's going to be -25x. Those are going to cancel out. And then that's going to also be -25. So x equals +1. Now we go back and plug it in, pick a spot. I'll plug it in right here. This looks fun. So if I plug in a +1, this would be 30 times 1 minus 8y equals 110. So that's just 30 minus 8y equals 110. So -8y equals 80. So y equals -10. Now this is actually for a shape, right? This isn't really like on a graph or anything like that. You could write it as a coordinate. I wouldn't take it off, but really it doesn't make as much sense in the context of this question. But y is -10, x equals 1, boom. So you're going to have problems, look at these three. You're going to have something like that on your test, guaranteed. All right, and then completing the square. I know this is what a lot of you here came for. Some of you guys skipped ahead to this. That's okay. Make sure you know how to solve systems. This is a fun thing to do here, guys, but a lot of people struggle to understand it. So I'm going to go through it step by step a little bit. Hopefully this makes sense. There are lots of people that this is just really confusing for. And even after showing you, it probably will feel kind of confusing. But the premise is, if I have a perfect square, right? Like if I have the square root of 49, that's going to be a whole number, right? Plus or minus 7. Or what if I have the square root of, x plus 7 squared, right? That would just cancel out. So there's a lot of uses to have perfect squares, my friends. So let's think about this. In order to take square roots, we have to know how to square things. So how would I square this out? We've gone over it. You can watch the other videos, but it's going to be the first number squared, right? If this is a and this is b, that would be 3x plus 2ab would be 6x plus 9. Hopefully you know how to do this. Try the rest of them. If you don't know how to do this, go to my other video. You need to know how to square a binomial. Not negotiable. This is x squared minus 14x plus 49. This one is x squared minus 20x plus 100. You need to know how to do that today. This would be a squared plus 2ab plus b squared. Okay, so keep that in mind. We only complete the square when your a value is 1. So if your a value is 1, isn't this spot always 2b? Let's look. This spot, negative 10, is that 2b? Negative 14, is that 2b? 6, is that 2b? Yes. If you know this middle number, can you figure out where it came from? That's the point of all of this. If you know what it looks like going forward, we can figure out what it has to look like going backwards. So complete the square. And actually, I want this to equal, I want you to tell me what it actually equals to. I meant to put this on there. What does it actually equal? All right. So x squared plus 5x, this spot right here is 2b. So what would be 1b? It comes from x plus 5, right? If I gave you this and told you to square it out, wouldn't you get x squared plus 10x plus what? Plus 25. 5 squared is going to be that last number. How about x squared plus 8x? What does it have to come from? Again, this is 2b, so 1b would have to be the number 4. Well, that means last times last is going to be plus 16. How about down here, minus 22? What would be 1b? Be minus 11. Well, negative 11 squared is going to be plus 121. Those are the numbers that complete the square for this problem. So let's take a hard look here. Would you understand what the square root of this is? Might be kind of hard to see. But if I gave you this equation, right, as you see it right here, and I said factor it, wouldn't be like, okay, what factors of 25 add up to 10? And that would be 5 and 5, right? And that what it would look like? And isn't that the same as what? X plus 5 squared. What is the square root of x plus 5 squared? Well, that's just x plus 5. That's a big deal. That is a perfect square. We completed the square. We took this, we added 25 to it, and we made it a perfect square. Now, keep in mind, when you add 25 to it, it is a different number. We're going to have to make adjustments. Let me show you what this looks like when we're actually solving by completing the square. So different teachers are going to show you different ways. This is just how I like to do it. Is first off, it doesn't factor. Let me show you. If I did x squared plus 12x and subtract 11, you have minus 4 equals 0. What factors of 4 subtract to equal 12? They don't exist. You cannot factor this. So they're like, uh-oh. So this is what you do. Is you leave these numbers alone, x squared plus 12x. We're going to leave room for some number that completes the square. And we're going to move anything else out of the way. I'm going to move the 7 to the other side. So it's a little different than what we're used to. We're not going to have it equal to 0. We're going to move our constants away. What completes the square? Well, if that's x squared plus 12x, what would make it a perfect square? What does 12 have to come from? 6. Well, what is 6 squared? What completes the square? 36. Now, if I add 36 to that side, what do I have to do? To keep it equal, this is an equation. I got to add 36 to both sides. So this has to equal 40. So now we take the square root of both sides. we get x plus 6, ooh, perfect square, that's why we do it, equals plus or minus 2 root 10, right? The square root of 40 is 2 root 10, and don't forget it is plus or minus. One more thing, we move the 6 over, subtract 6 over. Most teachers will say, hey, put that in front so you have that weird plus or minus symbol in between. It is negative 6 plus or minus 2 root 10, and we're done. You could write it as x equals plus or minus 2 root 10 minus 6. That is the same thing. It's just not traditionally how you see it. But it has to be a negative 6, and it has to be a plus or minus 2 root 10. So what did we do? We moved the 7 out of the way, subtracted it, we got 4. We left room for some number that would complete the square on these two terms. Well, if it's x squared plus 12x and you want it to be a perfect square, it has to come from the number 6. Well, x plus 6 times x plus 6 would end in a 36. 6 squared is where the 36 came from. So it is half of b, and then half of b squared is how you get these numbers. Well, if I add 36 to one side, I got to add 36 to the other side. So there's already a 4 over there, so it's 4 plus 36 gave me 40. Then I have a perfect square. I could take the square root. Well, the square root and the square cancel each other out, leaving me with just x plus 6. The square root of 40 is 2 root 10. Don't forget it's plus or minus. And then last step, I subtracted the 6. See if you can pull it off right here. I'm going to do it, but please try. Please try on your own. All right, x squared minus 16x plus some number is going to equal 7. I moved the 3 out of the way. What is that number? What does negative 16 have to come from? It has to come from negative 8. And if it's negative 8, then the number that completes the square would be 64. X minus 8 times x minus 8 would be x squared minus 16x plus 64. Well, I got to add 64 to both sides, so now I got 71 over there. Take the square root of both sides, and I get x minus 8 plus or minus root 71. It doesn't simplify. I move the 8 over. And I get 8 plus or minus root 71, and I'm done with that one. Great work, team. All right, one more situation. What about writing the equation of a circle using this skill? So that could be pretty hard. I don't know. There should be a little purple thing there. We're going to have to complete the square a couple of times. So we're going to complete the square on this. We're going to complete the square on this. We're going to move the 3 out of the way. So we're going to do a perfect square for x's. We're going to do a perfect square for y's, and then equals the constants. Remember that the equation of a circle is x minus h squared. That's a perfect square. Plus y minus k squared. That's a perfect square. Equals the radius squared. So this is the format we want it in, right? Like we want it to look like this. That's why we have this skill. It's why we're teaching it. So what do we do? Well, x squared minus 10x plus something. And then over here we're going to have y squared plus 2y plus something. Move the 3 over. It's going to equal 14. What is that something? How do you get a negative 10? What number would you have to square to get negative 10 in the middle? It would have to be minus 5. So we have to add 25. That would be 5 squared. Over here, y squared. What would we have to add to get 2? It would have to be y plus 1 squared. So we would have to add 1. 1 squared is 1. Now be really careful. We added 25 here, so we got to remember to add 25 to both sides. We added 1 there. We got to remember to add 1 to both sides. You have to add these numbers to both sides. This 25 did not exist. We put that there. And if we add 25 to the left side of the equation, we got to add it to the right side. So 14 plus 25 plus 1 would be what? 25, 30, 40. And we're done. That's the equation of the circle. The center would be 5 comma, here's the center, would be 5 comma negative 1, and the radius would be 2 root 10, right? This is r squared over there. All right, one more. You've watched me do it. You try to do it. Please try to do it. Please what? Try to do it. All right, x squared plus 20x plus something. Y squared minus 14y plus something, and I'm going to move that 110 over, so that's going to give me 40 over there. What is that something? Well, where does this have to come from? It has to come from x plus 10 squared, so that has to be plus 100. So I got to do plus 100. Plus, what does this come from? That'd be y minus 7 squared. Half of 14 is 7, so it'd be plus 49. So I got to add 49. And so what do I get? 189. I'm done. Woo! 189. What is the square root of 189? I don't know. I'm going to type that in real quick. It's 3 root 21. So what is the center? That'd be negative 10 comma 7. What is the radius? It'd be the square root of 189, which is 3 root 21. Nailed it. Nailed it. All right, guys. I hope you enjoyed that. Hope you enjoyed it. Have a good day.